All right, so we have 4 problems on margin of error in this mastery section. And let me start by talking about things in general here before we get to the problems themselves. The margin of error, you come along that margin of error when trying to learn about confidence intervals and sort of parsing them into their component parts. I hope what you've seen through your reading is, at least for the case of the mean where the population standard deviation is known, mean when the population standard deviation is not known, and the proportion, at least for those 3 cases, the confidence interval has the same canonical form. And actually that's true of the margin of error as well too. In all of those cases, the population parameter, whether it's the mean or it's the proportion that you are trying to bound, is bound by a lower bound, and that lower bound is a point estimate. In the case of the mean, it's the sample mean. In the case of the proportion, it's the sample proportion. And a margin of error. A point estimate minus a margin of error, let me just call it E, and a point estimate plus the margin of error. All of the confidence intervals look exactly that same way. They just change a little bit as the statistics change. It's also the case that all of these standard error, or all of these errors, are a critical value times a standard error. And remember, the standard error is the standard deviation for the various sampling distributions that you're talking about. So if we just write those down, for the case of the mean, where sigma is known, right, that E is equal to the critical value. The critical value in this case, since we're using the normal distribution, is Z alpha over 2, and the standard error in that case is written incorrectly right there, is sigma all over the square root of n. If we're talking about the mean, where sigma is unknown, then things change a little bit. Things change quite a bit. First of all, we move off of the normal distribution to the student t distribution, so this Z alpha over 2 becomes a T alpha over 2. And since we don't know sigma, we just replace it with S. So in this case, here is the critical value, here is the standard error. And finally, for the proportion, this margin of error is equal to, back to the normal, Z alpha over 2. This time, the standard error becomes P hat Q hat all over n, and P hat is the sample proportion. Q is 1 minus P hat. All right. So I think what I want to do now is fade away, erase the board. We'll come back. Well, I've had a change of heart about this video. I was originally going to do some problems on it. But I left out at the end of that prior shot that I left out an important part that I wanted to cover. And that's really what the definition of the margin of error is. And so we'll make this an intro, and then subsequent videos will take on the problems one by one. So let me go back to this canonical form that I wrote down. Point estimate minus E is less than or bounds on the lower end the population parameter, bounded on the upper end by the point estimate plus E. Okay. Let me subtract so you understand this statement is really 2 inequalities kind of conveniently jammed together. Let me subtract the point estimate from both inequalities. So I get over here on this side, minus E is less than the population parameter minus the point estimate. And on this side, I get positive E. So if you kind of think back to algebra class, maybe you recognize this as the definition of the absolute value. If you don't, it's okay. I can get you past this one way or the other. So right here is the difference between the population parameter and the point estimate. And what that says is that is always less than E. In other words, E is the maximum error. It's a fairly important quantity when what you're trying to do is to estimate a population parameter by giving an interval within which it should sit. Okay, the width of that interval is determined by this maximum error. And in fact, the way you'd say it is that E, let's see, I can always paint myself in the corner when I write this. Understand that in E is a critical value and a standard error. That critical value is totally determined by the confidence level. That confidence level gives a percentage, let's say 90%. And in the definition of E would then say if it was 90%, confidence level was 90%. The definition of E would say 90% of the time, the difference between the population parameter and the point estimate is less than E. Okay, so E is the maximum error between the point estimate and the population parameter and I want to say sort of parenthetically, and that is the case, a percentage of time so let me read it here to you. That's why this stuff is a little bit difficult to pick up while you're reading. So E is the maximum error between the population parameter and the point estimate. And that will be true for a percentage of the confidence interval estimates that you make, that percentage being given by the confidence level. Okay, so again, if we're dealing with a 95% confidence level, then 95 out of 100 estimates that you make in that same manner, it'll be the case that this product of the critical value and the standard error will bound the difference between what you're trying to estimate, the population parameter, and your point estimate. Okay, it's maybe enough for you to first and foremost get that this margin of error is the maximum error between the population and population parameter and point estimate. Okay, enough of that as an intro. Let's skip to the next videos, taking on one by one those 4 problems in this section. All right.